Hi, everybody. In this lesson, we're going to play around with Venn diagrams. And yes, it's the Venn diagrams that you think it's going to be. So this should be a nicer lesson. We're going to play around with Venn diagrams in the next two lessons next week and wrap up probability. And independence is going to come back, and these conditional probabilities are going to come back. So let's play around with this Venn diagram here. So let S be the event plays a sport, and B be the event plays in band. Based on the description of the high school below, fill in the Venn diagram. So in this Venn diagram, this S circle is the entire number of people of who's play sports. It's got two parts to it. It's got the just sports and the sports and band. This middle piece here is the sports and band, right? And then the band circle consists of two pieces. It's got the sports and band and then the just band. And then there's one more piece that people forget about, the outsiders, the people who don't do sports and don't do band. They're on the outside of those circles there. So let's see what they told us here. 442 people play in sports but do not play in band. So 442 goes here. It's this crescent, I guess this would be a gibbous, this gibbous moon here. 442 people play sports but do not do band. 31 people do band but don't do sports. So that's just this gibbous moon over here. 21 people do sports and band. So the 21 goes in the center there. And 339 neither participate in sports nor play in band. So that 339 is the outsiders. They make up the rest of the universe. So now when I ask you the question, how many people play sports? That's where you have to look at this entire circle. How many people play sports? 442 plus 21 gives me 463. This entire S circle is 463. And this entire B circle, how many are in band, is 52. I added those two numbers together. So you have to think, are they giving me the whole circle or are they giving me a part of the circle? How many students play sports or band? So the mistake that people do right now is they add those two numbers together, right? Sports and band, add them together. What we need to do, though, is add up the inside of the circle. So when we work with or probabilities is the sum of these three numbers that I just darkened too much. I need to find the sum of just sports, both, and just band. So when we find an or probability, I have to be in one of the circles. I don't care which circle I'm in. I could be both of them, but I have to be in one of the circles. Do not just add the whole circles together because you count the middle twice. Just add each of those pieces together there. So here's some vocab for us. We use set notation when we talk about these important words of and, not, or. So instead of writing out and, not, or, you're going to see me use these symbols. So when I say not A, what I really mean is the complement of A. And I use A with a little c as an exponent. So A with this c here means not A. The complement of A, don't be an A. An or probability is a union. Or I'm taking everything and pouring it into the same bin. So in a union, we use a U. A union B. That's A or B. Instead of writing or, you're going to see me use that union symbol there, that U, for the union of the two events. You're getting everything from A or B. I don't care which one I'm in as long as I'm in one of them. And then the and probability, we call the intersect A intersect B. It's an upside down U, and it kind of makes an A if you put a dash through it. A intersect B is the and probability, and we call it the intersect because that's where the two circles intersect. That's why we call it the intersect. So we've got three new words here, the complement, and I guess two new words. Intersect I won't use that much. But I have the complement of A, and I also have the union of two events. And you're going to see me use this upside down U, that cap, that upside down U, to represent and. You're not going to see me write and anymore. You're going to see me use that upside down U. So on the Venn diagrams below, shade the following probabilities. So we get to color here. Good thing I have lots of colors to pick from. Maybe this would be a great time to use the Galaxy pen. This will be a great Galaxy pen lesson. So I want the people who play sports. I don't care where they are, but they've got to be somewhere in the sports circle. So I have to be somewhere in here. That's my sports circle right there. I guess I'll cover everything because someone's going to leave a comment saying you missed a spot in this circle. So if I want to have the probability of sports, I've got to be somewhere in that circle. Notice it covers both. It covers that intersection. What about the students who play in band? Well, I have to be somewhere in the band circle. I have to be somewhere in here. I don't know where I am in here, but if I play in band, I'm somewhere in this circle here. So that's just band. What about the people who are not in sports? So I cannot live in the S circle. I have to be in this part of the B circle, but wait a minute. Don't forget about your outsiders. Your outsiders, I have to be outside of the S circle. I didn't say anything about whether I want you to play in band or not. All I said was you cannot be in the S circle. Let me make this smaller so it doesn't get as messy. So this is the complement of S because I'm outside of the S circle. And some of you right now are like, sir, you went over the lines. Sorry, I went over the lines. So the complement, look at these two. These two here complement each other. This is sports. This is not sports. If you put them together, what do you get? You get everybody. You get everybody when you put those two together. What about sports and band? The intersection. Well, the intersection, they have to live in that intersection piece. They have to live in that middle, that and. This is the and probability here. The and lives in the middle. What about the union or, S or B? S or B needs to be somewhere in a circle. I don't care where you are in the circle, but you need to be somewhere in a circle. You need to be in the S circle. You need to be in the B circle. You can be in both, but you've got to live in a circle. You can't be an outsider. So this is not the outsiders. You have to be sports or band. You have to be in one of them. So or probabilities, you add up these three pieces, just S, both, and just B. What about the students who do not play in sports and do not play in band? So they don't play in sports and they don't play in band. Well, that's talking about the outsiders there, isn't it? No sports, no band. They've got to live on the outside. You cannot be in the sports circle. And you also can't be in the band circle. So remember that there's really four pieces here. There's just S, just B, both of them, and the outsiders. There's really four different pieces happening here. So let's try this one. Suppose there are 230 students that play a sport, 190 play in band, and 60 play a sport and in band. There are a total of 500 students. So here's the problem. I can't put 230 in this Venn diagram. I know the entire circle is 230. I know the entire circle is 230. I know the entire band circle over here is 190. I cannot put those numbers in there because that's the entire circle. But what I can put in is 60 students play in both. So what that information does is let me put a 60 there. And now I can fill in those missing pieces by subtraction. The whole circle's 230. I used up 60. So let me find their difference. 170. 170 and 60 make 230. 130 and 60 make 190. But what did they tell me? They told me the total has to be 500. So how many kids have I used up? Well, let's add up these three guys. How many kids have I used up? I have used up 360 on the inside. There's 500 kids in total, so that leaves me with 140 for my outsiders. How many students play a sport or play in band? So this is sport or band. Or you add up those three numbers there. Sports, both of them, just band. That leads me to 360. How many students play in band? So I have to be in the B circle, but no sports. Band, no sports is this gibbous moon over here. I got 130. Suppose that a student is selected at random. what's the probability the student plays a sport and plays in band? So what's the probability of sports intersect band? Sports and band, there's 60 of them, and probabilities are always out of the total. 60 out of 500 comes out to be 12%. There's a 12% probability that a randomly selected kid is sports and band. So instead of talking about kids, let's make a Venn diagram for probabilities. So that 0.12 goes right there in the middle. 0.12 of them are sports and band. It's much easier to work with probabilities because it kind of takes care of everything. So 170 divided by 500 is 0.34. 130 divided by 500 is 0.26. And 140 divided by 500 is 0.28. And then it's probably good to say how big is the sports circle. The sports circle itself, the probability of sports is 46%. And the probability of band is 38%. It's probably good to realize what the whole circle is too. So the P of B is 38 and the P of S is 46%. All right, let's make a Venn diagram on our own now. So here's our online bookstore again. So our online bookstore sells a large selection of books. Suppose that 62% of the books are fiction. 47 of them are ebooks. All right, so let's see. I got fiction. So I got two circles here. I've got fiction and I've got ebooks. 62% are fiction. That's the whole circle. I can't put that in the circle because that's the whole fiction circle is 62%. 47 are ebooks. That's the whole circle again. I can't put that in. 14% are ebooks but are not fiction. So where does that go? Where does 14% go? They're ebooks, so it's got to live in the circle, but I can't be fiction. So that 0.14 actually goes right there. So let's finish up this Venn diagram now. I can use subtraction. I know this whole circle is 47. I used up 14. So 0.33 has got to be in the middle. Well, that whole circle is 62. So use subtraction again. I get 0.29. There's one more thing I left out, and that's my outsiders. So add these guys up. 0.29, 0.33, and 0.14. Together, they're 76 out of what? What's left over from 76%? 24% is left over. So 24% don't fall in either of those circles. So that's how we make a Venn diagram from these word problems. Find and interpret the following probabilities. So what is this? F and E. The intersection of F and E. Fiction and ebook. Well, that's easy. 33%. Done. That's fiction and ebook. The probability of me randomly selecting a book, that's fiction and ebook format. Versus this U here, that's F or E. So that's the probability of me picking a fiction or an ebook. And when we find or probabilities, we add up those middle three. We add up those middle three. And I get 76%. The probability of the complement of F, not F. So I cannot be in the F circle. I can't be this, I can't be this, but I could be one of these two. So 0.14 and 0.24 work for me. So that's 0.38. Or you could think about it. 62% are fiction. What's 100 minus 62? 38. If 62 are fiction, 38 are not fiction. What the heck is this saying here? So not F, so I can't be in the F circle, and not E. I cannot be in the E circle. So I cannot be in F, can't be in F, and I can't be in E, which just leaves me with the outsiders, 24%. That's the probability of me randomly picking a book that's not fiction and not an ebook. Almost done with Venn diagrams. When a fish is randomly selected from a tank, The probability that it has a green tail is 64%. The probability that it has red fins is 25%. And the probability it has both a green tail and red fins is 19%. I feel like I'm reading a Dr. Seuss problem here. So I've got green tails and red fins. Red fish, blue fish, one fish, two fish. So the entire green tail circle is 64. The entire red fin circle is 25, which leaves me with green and red. That I can actually put in the Venn diagram as 19%. So now I fill in the missing pieces with subtraction. 64 minus 19. 64 minus 19 is 45. 25 minus 19, 0.25 minus 0.19 is 0.06. And then don't forget about the outsiders. Add them up. I got 0.7, so what's left over from 100? If I got 70, what's left over is 0.3. If I had 0.7 inside, 0.3 is on the outside. So let's see what I'm looking for here. The probability of not green and not red. So I don't want to be green and I don't want to be red. Can't be red, can't be green. That leaves me as my outsiders of 30%. This is the probability of green, but I don't want a red tail, so not red. Green, got to be in the green circle, but I cannot be in the red circle, which leaves me at 45%. And then I also have green or red. Green or red. That's the or is those middle three there. Or probabilities are those middle three there. So 0.45 plus 0.19 plus 0.06 gives me 0.7. So hopefully you feel comfortable with these Venn diagrams. We always put the and probability in the middle, and then you can figure out the rest from that. I've got one definition, and then we are done. Two events are mutually exclusive. They're disjoint. They're mutually exclusive if they have no outcomes in common. So the probability of A and B equals 0. That means, if I get that, that means my events are mutually exclusive. They're disjoint. And it's really easy to see in Venn diagram form. There's A, there's B. What do you notice? There's no overlap. There's no intersection. Two events are disjoint. They're mutually exclusive if they both cannot happen at the same time. Both events cannot happen at the same time. I leave this for the Venn diagram lesson because this is the picture I want you to think of. When you see mutually exclusive, there's no and. There's no and probability, and there's no given probabilities. If you don't have ands and you don't have givens, if those are all 0, you have mutually exclusive events. Both events cannot occur at the same time. If you have a given probability, that means they can happen at the same time. But mutually exclusive means the two circles do not overlap. That's it for Venn diagrams, guys. We'll use them in the next 2 lessons to wrap up probability.